Assalamualaikum and a very good day to Dr. Azni Sahari and Madam Rahmah binti Syaril. I am Nur Izzati binti Zainuddin.
Assalamualaikum. My name is Rafatil Najihah binti Mat Khairi.
Assalamualaikum. My name is Nurul Amira binti Solihuddin.
We are from group P06S21. We'll be presenting a study entitled Solution of Linear Klein-Gordon Equation using Integral Iterative Method. Our group was supervised by Dr. Mat Salim bin Selamat. Now, I will present the abstract of our study. The Klein-Gordon equation is a well-known fluid mechanisms model. In our study, the integral iterative method is employed to obtain the solution for linear Klein-Gordon equations. 4 different problems of linear Klein-Gordon equations are chosen to be presented in an effective way. However, this equation is solved using integral iterative method. The results obtained by integral iterative methods are compared with the past studies which were using either homotopy perturbation method, semi-analytical iterative methods, or Haar-Wave-led collocation method. The result shows that the last equation for all the problems solved by the integral iterative method will lead to closed form of the exact solution.
The Klein-Gordon equation is a partial differential equation proposed by Oscar Klein and Walter Gordon in 1927. It is a unique equation since it has been used by both mathematicians and physicians. Due to its broad range of use, the Klein-Gordon equation has sparked a lot of interest among researchers in solving the equation. In order to solve the equation, a simple technique named Integral Iterative Method (IIM) is implemented into the equation. The IIM is working by selecting the initial condition and solve it via maple. For your information, a variety of approaches have been used by the past researchers to solve the linear Klein-Gordon equation. However, the calculation by using the previous method require a large computer memory during its computational process. Besides, the researchers also take too much time to solve the linear Klein-Gordon equation. Therefore, in this study, we introduce a new method named Integral Iterative Method to solve this problem. The objectives of this study are: firstly, to solve the linear Klein-Gordon equation by using Integral Iterative Method (IIM). Secondly, to evaluate the accuracy and efficiency of the IIM by comparing the result obtained with the past studies. One of the significance of this study is IIM is found as a solution to the linear Klein-Gordon equation. Secondly, this study also can ease the future researchers as IIM provides a simple way to solve the linear Klein-Gordon equation. Lastly, the calculation process will take a short time as IIM provides a simple way. Even though the Klein-Gordon equation consists of linear and nonlinear equations, but in this study, we focus on solving the linear equation only. Other than that, it's quite hard for us to find articles or reference regarding integral iterative method as it's rarely used by other researchers.
So now, I would like to explain more about the Klein-Gordon equation. So Oscar Klein and Walter Gordon proposed the Klein-Gordon equation in 1927. And it increasingly being used to analyze and control systems. Besides, the Klein-Gordon equation is a unique equation for physicians and mathematicians since it can be used to study physics plasma distribution, the movement of other waves, and quantum movement. And in its most general form, the Klein-Gordon equation can be written as we shown in the slide. Research done by Ikram et al. 2021, the Klein-Gordon equation can be solved using one-dimensional and two-dimensional Haar-Wave-led collocation method. As a result, the two-dimensional Haar-Wave-led collocation method indicates much better performance as its maximum absolute errors is in a small number of collocation points. For the last literature review, the homotopy analysis transform method (HATM) is used to solve the linear and nonlinear Klein-Gordon equations. Conclusively, this study concludes that the method can reduce the volume of computational work as compared to the classical method while still maintaining the high accuracy of numerical result. Now, we move to the literature review for integral iterative method. First, Hameda 2017 has conducted a study on solving nonlinear integral D differential equation by using the IIM. The obtained results show that the IIM is simpler, therefore, this approach is more suitable and convenient to be applied in order to solve nonlinear problems. Secondly, solving focal plane equation. The error analysis for the estimated solution is studied by using the absolute error and high convergence is obtained. This showed that the IIM is more reliable than other methods. Lastly, Kushadi et al. 2019 to obtain accurate solution to the Newell-Whitehead-Segal equation. Therefore, in conclusion, the results show that IIM will solve the nonlinear problems accurately and reliably.
For the methodology, we follow this flowchart as a guideline in order for us to successfully obtain the result and keep on track. Next is implementation. There are two steps in implementation. Step 1. Integral iterative method. Before we start to implement our method, we must know the general partial differential equation. Besides, the initial value problem is equivalent to u of x and t equals to f of x plus n of u. Right after that, the required solution u of x and t obtained recurrently by employing simple recurrence relation as shown here. Step 2. Implementing integral iterative method for solving linear Klein-Gordon equation. For your information, the first equation is the form of Klein-Gordon equation, while the second one is its initial condition. Note that Klein-Gordon equation can be written as u equals to f of x plus n of u, where n of u is the integration with respect to t. Then, by using IIM, the recurrence relation is as shown here, where r equals to 0 up until infinity. Validation. Validation of our method is by comparing the solution achieved by previous studies with our results. Example 1. We take linear homogeneous Klein-Gordon equation from paper authors by Ikram, Salim and Hussein in 2021. It is also given the initial condition together with the exact solution. This research paper used Hall-Wavelet method to solve linear homogeneous Klein-Gordon equation. From the example before, we solved the equation by using our method, IIM, where the equivalent integral equation obtained by substituting u equals to f of x plus n of u, which mentioned in implementation part. Then, we run the coding in Maple, and we obtain these iterations. Note that we stop at u3 as we can now see the pattern. Example 2. This example of linear non-homogeneous Klein-Gordon equation is taken from research done by Chaudhuri and Hashim in 2009. Together with it, it has initial condition, exact solution, and 5-term approximate series solution by using homotopy perturbation method. Then, by using IIM, the equivalent integral equation can be obtained by substituting u equals to f of x plus n of u. Next, we obtain the solution by using Maple coding to get these iterations, and we stop at u3 as we can see the pattern. Therefore, from the third iteration, we come up with general equation for finding the next consecutive iteration by the summation. Conclusively, the solution obtained is same as exact solution in previous studies done by Chaudhuri and Hashim in 2009.
For example 3, the linear non-homogeneous of Klein-Gordon equation is taken from research by Chaudhuri and Hashim in 2009. From here, we can see that given the initial condition along with the exact solutions, in this study, homotopy perturbation method is used to solve the equation. Next, we solve the equation by using IIM, where the equivalent integral equation obtained by substituting u equals to f of x plus n of u, which mentioned in the implementation part. Then, we run the command in Maple and these iterations are obtained. We stop at the third iterations as it shows the pattern. At this phase, we find out the pattern and simplify it. Thus, we obtain the summation form in order to find the next consecutive iteration. From here, we can see that The last equation will give the exact solution once the limit is taken.
Let us take a look on example 4. Consider the linear non-homo Klein-Gordon equation which research done by Ikram, Salim and Hussein in 2021, given the initial condition and exact solution as shown on the slide. Then, by using integral iterative method, we solve the equation in Maples until we get up to 2, since we already can see the pattern. Thus, for some positive integer at j and even integer m, by taking the limit for the last equation, will lead to the closed form of the exact solution.
As a result, the integral iterative method has been successfully applied to obtain the exact solution for the linear Klein-Gordon equation problems. The result obtained by the IIM is corresponding with the previous study. Therefore, this study shows that the IIM is simpler and reliable to be used to deal with the linear Klein-Gordon equations. As for recommendations, the future researchers can conduct a study on solving the nonlinear Klein-Gordon equation by using IIM.
Appendix. This is the Maple command for example 1, Maple command for example 2, Maple command for example 3, and Maple command for example 4.